Hello everyone and welcome to this video. My name is Noluthando Mthembu. I am a master's candidate from Stellenbosch University, South Africa. Today I'll be doing an educative presentation on an additive manufacturing technology called fused deposition modeling, or FDM in short. This is the outline of my presentation. Firstly, I will be describing briefly what additive manufacturing is, what the different technologies are in additive manufacturing, and why it is important. Following that, I will focus, or rather discuss, fused deposition modeling itself and the main components that are found in the FDM machine. I will then touch on the 3D printing materials or filaments that are used for this process. Right after that, I will explain the FDM manufacturing process step by step from start to finish, accompanied by video demonstrations. Later on in this presentation, I will highlight the main defects that is found in fused deposition modeling, and finally, where can this process be applicable. Before jumping into what fused deposition modeling is, let us just firstly describe what additive manufacturing is. 3D printing, as it's commonly known, is an additive, or rather a process of additively building up parts layer by layer to form a component or a 3D object. There are different types of additive manufacturing technologies in which, of course, each of them have their benefits and also their limitations, being able to print parts from different materials. These technologies include powder bed fusion, we have material extrusion, there's binder jetting, and more. The core strength of 3D printing is that parts can be printed in any simple or complex geometry. As mentioned, this video will strictly focus on fused deposition modeling, which is also known as fused filament fabrication rather. This process is the most common material extrusion-based additive manufacturing technology that uses thermoplastic polymers as filament materials. Now, what happens is the FDM uses a string of a solid filament that is coiled up in a spool, pushing it down through a heated nozzle and melting it in the process. The 3D printer then deposits the molten filament onto a build platform in a predefined path. Then the filament then cools down and solidifies to form a 3D object. The main components found in the FDM machine are: 1, the machine bed, which can either be normal or heated depending on the type of material used for printing. Number 2, there are stepper motors, which are responsible for the axial movement of the bed and the extruder, which can either move in X, Y, Z direction or all at once. Thirdly, there is the extruder setup, in which a filament coil is pulled up into, or rather pulled into, the heating zone. It reaches a melting point, and then it is deposited onto the build platform through the nozzle. The figure on the screen is our Creality Ender FDM machine that is available at our STC labs. Now, there can either be 2 spools in an FDM machine, one for the component material and the other for the support material, or one that acts as both, just like the one on the screen. Support structures may be required to print parts that are inclined just less than 45 degrees to the building plane, because new layers cannot be deposited onto thin air. Now, of course, this support structure is supposed to be removed after printing. Finally, there is the machine control unit, where instructions are given to the machine as a form of a G code. Now, let us look at the printing materials used in FDM. 3D printing materials can be classified into different types, as you can see here shown on the screen. However, for the purpose of this video, we will only focus on polymers, which can either be thermoplastics or thermosets. For the FDM technology, we will look at thermoplastics. Now, the main benefit of thermoplastics is that they can be melted over and over again without really losing their properties. So these are used as filaments, or rather filament materials for fused deposition modeling. Now in this slide, we see a list and not all of the filament materials that are typically used in FDM. We have PEEK, PEI, there's PLA, ABS, and more. Others may require higher printing temperatures for better engineering properties, but then this means that the more difficult it is to print them. For example, PEEK and PEI thermoplastics are generally printed using industrial machines that have greater control. PLA is the most common and it is the most, rather, it is easy to print with. Let us look at the FDM manufacturing process. This is the overview of the FDM manufacturing process. Firstly, you begin by designing a model using SolidWorks or software of your choice. Secondly, the file is then saved as a STL file and sliced using a suitable software as well. Then the G-code is generated and sent to the machine control unit. Thereafter, heating and printing begins. The following step is then to remove the printed parts, and then post-processing techniques are employed as per requirement. Now, the fun part about 3D printing is that you get to be creative. You get to see yourself design, or rather your designs come to life. You get to design anything in any shape you want, really, which, to be honest, can make you feel like a real engineer. Then you feed this information into the machine and the machine just does the rest. Now for this presentation, I decided to design a guitar because I love music. So that is why I decided to go for this model. Remember to save your file as an STL file, and then you are ready for the next step. For the slicing and G-code generation, I used an Ultimaker Cura software. You can use any other software that is, of course, suitable for the type of FDM machine you'll be using. I use this software to set up my parameters, that is the speed of printing, the number of layers before and after the infill material. Just remember that parts are not printed solid. So to save the material and also the build time, parts are printed with an internal low density structure called the infill. 20% is the most common percentage of infill material, and of course this increases as you want an increased strength in your material. Just notice how the build time changes as the parameters are being manipulated. So this process is to essentially just generate the G code that will then give instructions to the FDM machine. Now, once this is done, we do what we call bed leveling. Other machines do it automatically, but I'll just show you how it's done manually as well. So before this, the machine has to be auto-homed, as you can see here on this video. And then the next step will be to disable the steppers so that we can manually adjust the extruder and the nozzle together with the bed to do our bed leveling. The nozzle has to be a certain height from the building platform so that deposition is done successfully. And normally a piece of paper with a thickness of about 0.1 millimeter is used for this short height, as you can see in this video. So you can do this on as many points as possible on the bed. And then from there on, the nozzle and the bed platform are heated up to temperatures that you set in the G code, and then the printing begins. And now for the printing part. You are probably wondering why this guitar is surrounded by this weirdly looking shape. This is not for decoration. This is essential for dimensional accuracy. So to make sure that the bed is leveled properly and that the print, or rather the part you're printing, sticks on the build platform without any distortions that are influenced by uneven cooling, a few test layers are printed before the actual part so that adjustments are made if they are needed. And there you have it, doing the final layers, and then you have your part. The next step is to then remove the printed part. So print removals can be as simple as shown in this figure by grabbing a pair of metal spatula to remove the part, while other industrial 3D printing methods can be very technical, in which strict removal procedures are required with highly skilled machine operators following a set of safety rules in controlled environment, and etc. Post-processing differs with additive manufacturing technology. Some technologies require that a part is cured under UV light before using, while others just allow the part to be handled right away. So this table shows the most common post-processing options. The first one is the compulsory type. So this is when a design was printed with a support structure. This support structure has to be removed after printing by either cutting it off or breaking it off. The surface rather that was in contact with the support material will typically have a rough finish, so sanding can be employed to smoothen the surface. Surface finish can further be improved by light sanding with a grit paper of not less than 600 grits, because some FDM plastics are soft. Gap filling with an epoxy resin can also be done to smoothen surfaces. For design that need to be broken down into smaller parts because of build volume restrictions and whatnot, cold welding can be done to connect these parts together, and we can use an acetone solution rather for this. And then for aesthetics and for that final touch, polishing, priming, printing and plating can be done on the printed parts, and then you have your beautiful part. But now, what is the downside? What are the discontinuities that occur during the process of fuse deposition modeling? When a portion of the component does not stick properly onto the build platform due to differential cooling, that is shrinking and contraction, there is the creation of what we call residual stresses or internal stresses that lead to distortion. So when this happens, we have what we see here on the screen, and this is called delamination, or you can refer to it as warping. Before I close off this presentation, and on a lighter note, in which field can the FDM method be applied? What can be made out of this process? And to answer the question, almost anything really that you can think of. The low cost of FDM materials and the intricate geometries that this process is able to produce makes it very ideal for making investment casting patterns, electrical enclosures, prototypes for the aerospace industry, medical fields, for art decorations, or rather art industries, and the list goes on. On the right are some of the many objects that were printed in our STC labs. We see a beautiful vase where you can put your beautiful flowers. There is a tool holder there for machinery. There is also a cool flash drive and many more. Thank you very much for tuning into this video. Do go on to check our STC Lab website by clicking on the link provided on the screen to learn more about additive manufacturing and the concept as a whole. Until next time, goodbye.